Hello there, and welcome to the December 2023 edition of the Manitowoc Ice Monthly Spotlight. I am your host, Jason MacDonald, Technical Service Trainer here for Manitowoc Ice, and today we're going to be talking about the NEO under-counter refrigeration system and how to diagnose components within that system. So give us a second here to get the screen sharing going so we can share your presentation. As we do with all of our spotlights, there will be a quiz at the end of this seminar, and to receive a copy of the presentation and a certificate of completion, you're going to need to complete every one of the questions. We're going to be looking for things like who you are, who you work for, specifically your email address, because that's how we're going to contact you. And then you need to click submit at the end of the quiz. If you don't click submit, we're not going to get that record. We're not going to know you did it. And we're never going to be able to reach out to you because we don't know who you are. So answer all those questions, try to get all those questions right, and we'll reach out to you with a certificate of completion and a PDF version of the presentation. So we're talking about the NEO refrigeration system here. We're going to start with the thermal expansion valve, or TXV. So we have a model here we're going to talk about. It's going to be a U0190A-161B. That U is calling out that this is an under-counter ice machine. That D is letting us know it's a Dice Cube evaporator. In 2018, we started calling out the refrigerant type. That F, as in Foxtrot, is going to let you know that this is R404A refrigerant. And then the series is the 0190. That's letting us know that this ice machine could make 190 pounds of ice in a 24-hour period if it never shut down on a service limit or never shut down on a full bin. Should one of those two things happen, however long the unit is off, that's going to be lost production. So we won't get to that 190 pounds at that point. But then we have the letter A as an alpha. That's letting us know that this is an air-cooled condensing option. Then we got the -161. That tells us that this is a 115 volt, 60 hertz, single phase unit. And the B is in Bravo. That's letting us know that this ice machine shipped with a cord that had a plug on it. But let's go ahead and start talking about how to diagnose a starving or flooding TXV. You're going to need a few things to do this. You're going to need to know suction and discharge pressure, status of the bulb for the expansion valve, compressor discharge line temperature, the temperature to the inlet of the harvest valve, and the evaporator inlet and outlet temperature. So we're going to start with suction and discharge pressure. All right, here we have on the left the 8 psi on our suction gauge there, that blue gauge. That's pretty low for freeze. And then on the right, we've got 50 psi on the red discharge gauge. Everyone at Manitowoc Ice in the technical service department, whether it's the technical service associates and territory service managers taking your tech support phone calls, or us here in training and development, will tell you that those pressures, those are not good freeze pressures. Even in harvest, those pressures don't make any sense. So you're going to find that this system's low on charge. The odds are that you've got a leak somewhere or somebody's engaging up to it for no reason over and over again. In this example, we're going to say that the system is low, and you're going to need to go find yourself a leak, fix that leak, charge that system back up to the nameplate weight, and start reevaluating from there. Remember, if discharge pressure is too low, as it is in this example, or if it was too high, you need to resolve that before you go any further when doing a refrigeration analysis. But okay, so we fixed our charge issue, and now we're going further. We've got 273 psi on our high side. That makes a lot more sense in accordance with the technician's handbook. And we still have 8 pounds of suction, 8 psi. That's really low. So at this point, we know there's something going on with the refrigeration system, but we know it's not low on charge. So at this point, we're really going to want to start diving into what else we need to figure out here. So we want to check that TXV bulb. We're going to want to know what's going on with the compressor discharge line temperature. The inlet side of the hot gas valve, that should be cool enough to hold on to. It should not be anywhere near the heat that we're supposed to be building up on the discharge line. For those of you who don't know, 150 degrees or more at the end of a freeze cycle is what we consider normal for the compressor discharge line. We're building up heat on purpose. We need that heat. Harvesting ice is hard and it takes heat. And we need the inlet and outlet temperature of the evaporator to see what's going on. All right, so we've got a refrigeration diagram here, and we're going to check a few things. We're going to check everything that's just got circled. So at the very top there, that's going to be the bulb to the TXV. You're going to want to verify that it's properly insulated, that that line isn't crushed for any reason, that it is mounted correctly, and that there's no sort of light coming through there. You shouldn't be able to see light. It should be tied up against the copper tubing that it's clamped to. But in this example, that's not what we're going to find, so the bulb is good. But that's circled right down there by the compressor. That's our discharge line temperature. Again, should be at least 150 by the end of a freeze cycle. And then that second circle to the right, that's going to be the inlet to the hot gas valve. During freeze, you should be able to leave your hand on that comfortably without any issues. The next two circles, the one right there by the TXV, that's the inlet of the evaporator, and the one right above it is going to be the outlet of the evaporator. We're looking for what's the difference there? What's the differential between the two? Typically, I would expect them to be within 7 degrees. But for this example, our discharge line temperature is going to be 190, and this is 6 minutes into freeze that we checked, all right? That's pretty hot. I did say 150 is normal, but early in freeze, I would not expect 190 degrees. But the inlet of our hot gas valve, we grab onto it, it's fine. You can leave your hand there all day, no issues whatsoever. So we don't have an indication of that leaking by. If that was leaking by, which we'll talk about in further slides, if that was leaking by, it would be just as hot as the discharge line. But how about the inlet and outlet of the evaporator? We're going to say for this one, we're 28 degrees on the inlet, but we're at 50 degrees on the outlet. Well, that's a much greater than 7 degree swing. That's what, 22 degrees? So that's going to be an issue there. Should you see this, normal head pressure, which we are at 273 PSI, basement level, bottom of the barrel level suction pressure, we were at 8 PSI. That's really low. We shouldn't be anywhere near that even at the end of a freeze. And our inlet and outlet are within 7 degrees, hot compressor discharge line. Hate to break it to you, we got a starving TXV on this ice machine. It's time to go to the local Manitowoc distributor, get a TXV and a dryer, cut those out, replace them, charge the system up to the nameplate weight. Again, you can always find that on the data tag inside the ice machine. It'll tell you what type of refrigerant is in the unit and how much it'll take. All right, but what about the harvest valve? Just talked about a TXV starving. Now we're going to talk about how to diagnose a harvest valve. So the way the valve works is during freeze, it's supposed to be de-energized. So you should have 0 volts across it when you're in freeze. And it's supposed to be energized in harvest. On our wiring diagram there on the right, it's going to be component 4242. And you'd be able to see in your technician's handbook when you look at the electrical there, every one of those numbers will have a label saying, hey, 42 is the hot gas valve, letting you know what you're looking for. All right, but to diagnose a leaking harvest valve, you're going to need 4 things. 5 things, really. Suction and discharge pressure, compressor discharge line temperature, evaporator inlet and outlet temperature, and your harvest valve inlet temperature. And we're going to want to verify power to the valve. For refrigeration purposes, it's 4 things, but overall, we want to verify power, so it's going to be a 5th thing. All right, so we're looking. Ooh, 168 on the high side and 93 on the low side. Well, if I open up my technician's handbooks to page 226 for this series of ice machine, those pressures look like they do in harvest. So, hey, if you need to verify the charge is your issue, that I would not stop you from doing that whatsoever. But for this example, we're not going to pull the charge again. We've already done it on a previous machine. So we're going to see what else is going on with this ice machine. Again, page 226 on the current revision of the Neo Technician's Handbook for a U0190A series ice machine. Regardless of voltage, regardless of cube type, it would be on page 226 of the current Technician's Handbook. All right, so we've got our refrigeration diagram here again, and we're going to be looking at a lot of those same things. We're not checking the TXV bulb this time because we're not looking at a TXV issue, but we're going to take the temperature of the compressor discharge line. We're going to take the temperature of the inlet of the hot gas valve. And we're going to take the inlet and outlet temperatures of the evaporator. Well, in this case, we're talking about a valve that might be wide open. So, hey, we've got 190 degrees again on the discharge line, but the inlet side of the hot gas valve, it is too hot to handle. It's that same 190 degrees, maybe it's 188 degrees, but we have an indication that discharge gas is running through that valve. If it's running completely through that valve, the odds are your inlet and outlet temperatures are going to be very close to each other, especially if it's wide open. You might actually see that thing steaming the water that's going over the plate, and that's one of the keys that'll let you know that you're not in harvest. You've got water going over the evaporator, especially if this has been going on for 6, 7, 8, 9 minutes. You're in freeze. Look at the lights on the board, verify that harvest light is not lit, check the status of your float lights, low level float, high level float. If they're both lit, harvest light is off, you are not in harvest, you are in freeze. You have water in the trough and you have water going over the evaporator. We're in freeze and we've got harvest type pressures. So we've got an indication that this harvest valve is leaking, but there's one more thing we want to check. We want to check for power. So again, we've got our pressures. They look like harvest pressures in accordance with page 226. So let's go and see how we verify power to this valve. Two ways you can check it. Here on that picture, you're going to see the red lead is pushed into the middle bottom wire there. That's a red wire number 6. And the black lead is pushed up in the top right there into that blue number 2 wire. So wires 2 and 6, that'll let you know, do we have power coming from the board going to the hot gas valve? Or you could go straight to the valve itself. Go ahead and disconnect those wires from there, wire 6, and then the blue wires 8 and 7 jump to each other. Check across those. Do you have 115 volts? If you do, verify, hey, are you in harvest? Is the harvest light on the board lit? Are the float lights out? If they are, hey, we're in harvest. If they're not and you have power, that's going to be a stuck relay on the board, but we're not really talking about board diagnostics. We're talking refrigeration system. So for this example, you don't have power at either of those two places. Or you've got ghost voltage. Hey, I saw 3.2 volts. Well, we're looking for line voltage. On a 115 volt unit like the example machine here, I'd expect to see 115, 117 on a 208, 230 volt, whatever line voltage is coming through, we'll call it 214 volts, but you don't have that here. So we are not getting power from the board to this valve, but we're heating the plate. Well, in this example, if that's what you're seeing, harvest pressures, a hot compressor, and a hot inlet to the harvest valve, that valve is leaking by. Physically, mechanically. At that point, again, we're going back to the Manitowoc part house. We're getting ourselves a hot gas valve and a filter dryer. We're going to cut those out, use good refrigeration practices, and purge with nitrogen. We're going to braze in new, charge back up to the nameplate weight, and we'll be back off to the races making and harvesting ice. All right, but what about that harvest valve in harvest? Again, as we showed you, you can verify if you have power. So go across wire 6 and 2 at the board, or go across 6 and the jump together 7 and 8 wires during harvest to verify, are we sending power to the valve? Well, what are our pressures doing in harvest? Again, page 226 will tell you what's going on, but these pressures here on the screen, those are freeze pressures. Well, harvest light's lit. Water's out of the trough. You heard the valve click on, you've checked for power, you've got 118.1 volts. We have power. On this air-cooled unit in the example, well, we're above the cutout of the fan cycle switch, and our suction isn't rising. In this case, what's happening to us is the harvest valve is failing to open in harvest. What would be happening is you would not be melting the ice, and the fan would continue to run in harvest, which is a good sign, not a telltale definitive answer. That's where the pressures come in. But in this example, you have higher than normal head pressure, lower than normal suction pressure during your harvest sequence. That's going to be a harvest valve failure all day. Go ahead and get yourself a new harvest valve that will open during the harvest, and we're going to start harvesting ice again. Remember, though, if you see something along these lines and you're trying to verify what happens in harvest, you have to have a good freeze cycle first. Have to make a good sheet of ice, have to be able to get through those things before we diagnose a harvest. All right, but what about the compressor? In this example, we're going to be talking about the compressor is running, but we're not making ice. The key to that is we're going to talk about a compressor that isn't running, but we're not making ice here. So to diagnose a compressor, we're going to need that suction and discharge pressure again, compressor discharge line temperature. We want the inlet side of the hot gas valve just to verify that we're not misdiagnosing and chasing the wrong component, and the evaporator inlet and outlet temperatures. So what are our pressures doing? Well, we're at 285 pounds on the high side. Again, normal. 226 in your technician's handbook. That is a normal head pressure, but suction's at 93 psi. And we took this information down at 6 minutes in freeze. That's a real high suction. So let's try to see what's going on. We got to get that other information. All right, again, we're at our refrigeration chart, and we're going to take that same information again. So compressor discharge line, we're going to take temperature there. Hey, we just grabbed on to the harvest valve and it's cool to touch, so no indication of leaking there. And then we're going to look at what the inlet now the evaporator's doing. So for this one, we're at 196 degrees on the high side. Or sorry, we're at 196 degrees on the discharge line. So we're getting hot again. Remember, 150 is normal at the end of a freeze. If you told me you were at 165, 170, I wouldn't be too concerned. But 196 degrees at 6 minutes, and we don't have ice, we're looking at a problem there. Well, we grab the inlet of the harvest valve, like I said, it's cool enough to touch, so we can stop trying to diagnose that. And the inlet and the outlet of the evaporator, they're both sitting at, well, let's call the inlet at 54 and the outlet is sitting at 57. they're within 7 degrees. So if you see all of this, compressor's running, you hear it buzzing, contactors pulled in, and those temperature profiles, you have a compressor that's inefficient. It's not pumping. You need a new compressor and a new filter dryer. Replace those components, this ice machine will be back to making ice. All right, but we're still in the refrigeration system, and we're still on the compressor. What if it's not running and we're not making ice? Well, obviously, if it's not running, we're not going to make ice. But there are a number of reasons why a compressor would not run. So we're going to look at things like our pressure switches, that picture in the bottom left. Our condenser fan motor, does it run at all at any point? The contactor, hey, is the contactor pulled in or not pulled in? And why does that matter to us? Well, we'll get to that. And if we were talking about a water-cooled unit, which we're not really highlighting because the 190 only comes in an air-cooled option, we'd be looking at what's going on with the outlet of the condenser. Is water coming out of the condenser drain? If it is, we need to see what's going on there. All right, so let's check, is the contactor pulled in? If the contactor's pulled in and the compressor is not running, go ahead and check your star components. But if they check out, they ohm out, they read the right microfarad readings, all those things, well, then we're looking at a compressor that won't start. Or let's say that compressor runs for a little while and then it stops. Again, let's verify, hey, is the contactor pulled in? Yes, contactor's still pulled in. All right, we checked that, compressor stopped. Might have been hard to get an amp clamp on there, but if you've got no compressor running, power to the contactor, good starting components, they check out just fine. You've got an open overload, you got a tripped overload, and at that point, you're going to be looking at a compressor again because that overload's internal. And if it just repeatedly trips the overload, there's something wrong with the compressor, with the internals there. You're going to need to get a new compressor, new filter dryer, and we'll be back off to making ice. But what if the compressor stops and the contactor unpulls and we're not getting voltage to the contactor? That's key. Because, hey, if the contactor just chatters or unpulls, but it's getting voltage, well, we're looking at a contactor. But what were our pressures doing before all this happened? What was the condenser fan motor doing on an air-cooled unit? Like we were saying before, what's going on with the outlet to the water-cooled condenser? Were we getting water through it? And what's the status of the high-pressure cutout? So we're going to talk about those things now. All right, so compressor isn't running, we're not making ice, and we're talking about a air-cooled ice machine. So we've got a couple of charts up here letting you see what goes on with the fan cycle switch and what the fan should be doing when this is happening. So we were talking about a UF 190. That pressure switch closes at 250 plus or minus 5 PSI, and it cuts open at 200 PSI. Well, we're looking at a machine, we got 51 pounds of suction, and we got 445 PSI on the high side. Well, if the fan is not running, that's a big problem because the high pressure switch, it opens at 450, it cuts open, cuts out, we're going to shut down. Well, what's going on with the fan? Well, if you go straight to the fan switch, if you're above the cut-in, you're above 250 like we are on the screen here, sitting at 445, I should have 0 volts and that fan should be running. Well, if I have 0 volts and the fan's not running, well, the odds are the fan motor is defective and we need a new fan motor that will run when it gets power. But what happens if we're above the cut-in and we have line voltage? Well, that switch, it didn't close. The switch doesn't close, the fan doesn't run. So one of the things that I'd be doing or telling you guys to do, or anyone here at Manitowoc Ice and tech support would be telling you to do, if you couldn't check there, one fast way to verify, is it the switch or is it the fan? Go ahead and pull those wires off of the fan cycle control switch, jump them to each other. Once that contactor pulls in, that fan should run constantly. We'll be sending straight power to the fan at all times because one side of that pressure switch is tied to the load side of the contactor. So if the contactor's pulled in and we jump the wires to each other, fan should be running. If it's not, you know it's a fan motor problem. If it does, but it wasn't before you did that jump, well, then you know it's the fan cycle switch. Go get yourself a new fan cycle control switch, get yourself a filter dryer, cut those out and use good refrigeration practices, braze in new while purging with nitrogen, and let's get this customer back going. But what about that high pressure switch that we're talking about? If it's defective, what if we're below that 450 PSI? And we're reading line voltage? Well, hey, defective switch. Not something I see a lot, not something I think any of my coworkers see a lot. Very rarely do we diagnose high pressure switch issues on the machine. But if you had a faulty high pressure switch, you're dealing with the same issue. It's tripping when the head pressure is well below. Now remember, if it tripped and it has not gotten below, you need to get to your technician's handbook and see where that pressure switch resets. It's an automatic resetting switch. It will reset at 300 psi. If all of a sudden the contactor clicks in, then let's start looking at the fan again, or see what's going on with water on a water-cooled unit, see what's going on with the water reg valve, water supply, those kind of things. But if you do have a defective switch where it's cutting open before it gets to anywhere close to 450 psi, well, then you're looking at an issue with that pressure switch. And similar to what we just did with the fan switch, you're going to be brazing in a new switch and a new dryer, except this time it would be the high pressure switch. Again, good refrigeration practices, purge with nitrogen, get that customer up and going, and we'll be good to go. So I'd like to thank all of you for coming today. A couple of upcoming webcasts that we have. Next month in January, we're going to go over the Indigo Next cleaning procedure. It's similar for a lot of our modular units, other than how the screen operates. Cool Air, you do a lot of the same things as well, just an extra thing to pull out of the system, and you don't have a screen. So we're going to go over cleaning. Cleaning is one of the favorite topics of this department, so we're going to highlight it every single year. Then in February, we're going to talk about modular cool air safety limits. In March, we're going to talk about how discharge pressure can impact things, whether it's high, it's low. So I'm going to go into another refrigeration related topic, but we're going to cover really the gamut of our platforms, at least modulars and undercounters. In April, we're going to talk about the Crystal Craft Premier. Sorry, we're going to talk about the Crystal Craft, the USC 50 Crystal Craft Premier, and we're going to talk about its service limits. There's 5 of them on that machine. In May, we're going to talk about Indigo and Indigo Next control board lights and what they mean. And then in June, we're going to talk about the Neo and Cool Air, modular Cool Air control board lights and what they mean. Neo and modular Cool Airs, they share a board, so we're going to cover them both together. So that's what we've got coming up for the next 6 months. Hope to see you at those. But one thing I do want to highlight, and I'm going to give a chance for this just to stay on the screen. If there's a topic you want to hear us talk about, whether it's with our Ice Tech Fact series, the 5-minute or less videos, or our monthly spotlight series as you're watching today, this QR code and URL will let you tell us what you want to see. What topic do you want us to cover? Gives us an idea for content, gives you a chance to see what you really want to see, especially if it's something we haven't covered in a while. But going to leave this up for about another 15 seconds and we'll start talking about your quiz. All right, at the end of our spotlight, you're going to see a QR code. Again, this is computer or mobile friendly. And we do like to show you there that we have our registration available for the Level 3 factory school. We've had all the way through December, and our registration for January is full, but those February classes and March class, they're going to be available. So if you're looking for in-person hands-on training, please reach out to us via the website or the phone number that you could reach me at to discuss the factory school. Again, you have to click submit at the end of this. Otherwise, you're not going to get any sort of feedback from us about the quiz results. You're not going to get the presentation or a certificate. So you got to click submit on there. That lets everyone here at Manitowoc Ice know that you took it. And as we've been doing, we're still going to give out the monthly swag bag. Still doing the same stuff there, that tape measure, some Band-Aids, lens cleaner, got a letter opener, nice Manitowoc Ice hat, and a snowflake Manitowoc Ice tote. So for every 25 quiz submissions, we'll draw a name. And if we had 50, we would draw 2 and so on. By the end of the month, once the next spotlight is up, is when we'll draw for this one. Once this one is up and available to you, we'll draw for the last one. And again, Manitowoc Ice employees, I'm sorry, you're still not eligible to be entered into the drawing. But again, this is the QR code. This is where you'll be able to see the questions to the quiz, and that URL link is going to be up there as well. We will put that onto the YouTube comments section, so that way if you are on a computer, you don't have to try to copy and paste this somehow. You can just click that link and go to the form. We're going to leave this up. I would like to thank all of you for coming today or watching at your leisure and seeing what we're talking about when it comes to the Neo undercounter and its refrigeration system. If you are liking our content and want to know more, please like and subscribe on our YouTube channel. If you search Manitowoc Ice, find our snowflake logo and like the channel. It'll let you know when new content comes out. Again, my name is Jason MacDonald, Technical Service Trainer. Thank you for coming. We're going to leave this up for a while so you have the chance to take your quiz. Good luck.